Mass of the proton is so much, mass of the neutron is so much. 7.01022 AMU. So this is the actual mass of the lithium-7 nucleus. Binding energy is mass defect into 931 MeV. The element which has more specific binding energy will be more stable. Hello students, this is SD Sir from the Temple of Excellence, Vidhyaashram Pre-University, Mysuru. In my today's session, I will be working out problems from the chapter Nuclei. Hope you people have come prepared. You have gone through my previous session, ready with the concepts, ready with the topics. We start solving problems from the chapter Nuclei. Very interesting problems. The first one. The first problem says, the mass of deuterium nucleus. Yav nucleus kottidare? Deuterium nucleus. The mass of deuterium nucleus. Deuterium is represented as H12. 1 is the atomic number, charge number untlu karitivi. 2 is the mass number, which means deuterium has 1 proton and 1 neutron. So, remember students, deuterium H12, where it has 1 proton and 1 neutron. And therefore, the mass of the deuterium nuclei is 2.01410 units. Atomic mass unit. The mass of proton and neutron are given to be 1.00728 units and 1.00867 units respectively. So, mass of the proton is so much, mass of the neutron is so much. I have to find the mass defect and binding energy of the deuterium nuclei. Mass defect delta M ant karadvi. What was this mass defect, students? Difference in the sum of the constituent nucleons and the actual mass of the nucleus. So, we have been asked to find the mass defect and binding energy of the deuterium nucleus. To begin with, now I told deuterium is H12, which has one proton and one neutron. So first I will find the mass of one proton plus mass of one neutron. This is because deuterium comprises of a single proton and a single neutron. So first I find the mass of one proton plus one neutron. So this is equal to, what was the mass of the proton given to be? 1.00728. So 1.00728 plus, what is the mass of neutron given to be? 1.00867. So 1.00867. So this is equal to 2.01595 units. So this is the mass of, or I can say the sum of the mass of a proton and a neutron in the deuterium nucleus. But mass of deuterium is given to be 2.01410. 2.01410 units. This is the actual mass of deuterium nuclei. This is the sum of the mass of the constituent particles. Therefore, mass defect delta M is 2.01595 minus 2.01410, which turns out to be 0.00185 units. So these simplifications, see that you take care and perform. Now once mass defect is calculated, what is binding energy equal to? Delta M into 931 MeV. Please know this. Binding energy is mass defect into 931 MeV, which will be 1.77 or 1.722 MeV. So this is the binding energy of the nucleus. So mass defect you have to subtract the sum of constituent nucleons mass with the actual mass of the nucleus. Binding energy is that mass defect into 931. Next one, students. Now, the mass of lithium-7 nucleus. ಈಗ ಯಾವ ನ್ಯೂಕ್ಲಿಯೈ ಕೊಟ್ಟಿದ್ದಾರೆ? lithium 7. So lithium 7,3, which has 3 protons and 4 neutrons. How do you calculate the number of neutrons? 7 minus 3. Mass number minus atomic number. So the mass of lithium, which has 3 protons and 4 neutrons, is 7.01022 AMU. So this is the actual mass of the lithium-7 nucleus. Calculate the binding energy per nucleon. So we are calculating the binding energy per nucleon given the mass of one proton again is 1.00728 and that of neutron is 1.00867. So ಎಷ್ಟು ಪ್ರೋಟಾನ್ಗಳಿದೆ ಇಲ್ಲಿ? 3 protons. ಎಷ್ಟು ನ್ಯೂಟ್ರಾನ್ಗಳಿದೆ? 4 neutrons. So I have to calculate binding energy per nucleon. Again, to start, calculate mass defect, binding energy as we did in the previous problem. One additional step where you have to calculate the binding energy per nucleon. Now, mass of 3 protons plus 4 neutrons. First ಏನ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತಿದ್ದೀನಿ? Mass of 3 protons plus 4 neutrons. So this is 3 into 1.00728 plus 4 into 1.00867. Correct? 3 protons ಇದೆ. Mass of each proton 1.00728 into 3 plus mass of one neutron 1.00867. So 4 neutrons. So this turns out to be 7.05652 atomic mass unit. So this is the mass of the constituent nucleons. Now, mass of lithium 7 is given. So mass of lithium 7, 7.01022. So this is 7.01022 units. So this is the actual mass of lithium 7. So mass of the constituent particles of lithium, this is the actual mass of lithium. So delta M, mass defect, 7.05652 minus 7.01022, which is equal to 7. We minus them. So now binding energy is so much into 931. So this turns out to be 43.1 MeV. So these are the simple calculations which I expect you all to perform. Now I have got the binding energy, but I have to find binding energy per nucleon. So binding energy per nucleon divided by A. So 43.1 MeV divided by 7. Mass number is 7, which is nearly 6.157 MeV. So this is the binding energy per nucleon. Step by step, link to the solution. In this chapter, especially here, if you know the concepts, arriving at the relations and the calculations becomes very, very easy. Next one. Calculate the energy equivalent of mass. Energy equivalent of mass of the electrons at rest, which is equal to 9.1 into 10 power minus 31 kg. So the moment I say energy equivalent of mass, what do I get into picture? Good. Einstein's mass energy equation. E is equal to mc square. What is the mass of the electrons given? 9.1 into 10 power minus 31. So this is 3 into 10 power 8 whole square. Or simplifying this, 9.1 into 10 power minus 31 into 9 into 10 power 16, nearly 9 into 9, 81, minus 31 plus 16, nearly 10 power minus 15 joule. But energy has to be in electron volts. So simplifying it in terms of electron volts, so this is 81 minus 15 divided by 1.6 into 10 power minus 19 divided by the charge of the electron, which is 0.511 MeV. So this will be the answer. The next one. We will do this as an assignment problem, but I will give you the ideas. I will give you the concepts. I expect you all to find it out. Calculate the specific binding energy of ferrous 5626 and cesium 13355. Mass of ferrous is given, mass of cesium is given, mass of proton is given, mass of a neutron is given. Specific binding energy. What is the specific binding energy? That is nothing but binding energy per nucleon, as we did in the previous case. First, we will calculate it in the case of ferrous 5626, which means there are 26 protons and 30 neutrons. 26 protons, atomic number, charge number antu karaduve. 56 minus 26, 30. So here, I calculate mass defect as delta M equals Z MP plus A minus Z Mn. We also have this expression for mass defect. Z, atomic number. MP, mass of each proton. A minus Z, neutron, mass of each neutron. So that will give you the mass defect, so many units. Now from this, binding energy is delta M into 931 MeV, so many units. Finally, it is for binding energy per nucleon, specific binding energy. So this will be for ferrous 5626. Similarly, repeat all steps for cesium 133. Same, calculates its mass defect, binding energy per nucleon, which is more stable. The element which has more specific binding energy will be more stable. So see, the same way of calculations. Again I say, if your concept depth is more, you can arrive at the solutions easily. In my next session, I will solve few more problems from nuclei, interesting problems from radioactivity. Until then, have a nice time. Thank you.